So all we're doing today, though, is I'm just going to have you guys graph vectors. Okay, we're just going to plot them and work with that because I've noticed that most of my students struggle with just this lesson. And it's not so much because it's difficult, but just because you guys have a hard time understanding how to graph it when you guys are used to plotting points on a plane. Okay? So I kind of removed all the other stuff with it, and we're just going to graph today. Make it a whole lot easier. Okay? Now, what I mean by basic operations is just addition and subtraction. See me, Zena? Yeah. All right, so vectors look like this. They have a clear point. Ooh, that was really crooked. And an arrow. Okay, so vectors have two things. They always have a distance, a length, a magnitude, and a direction. Okay? So the proper name for the distance of a vector is magnitude, okay? But for now, I'm just going to put length because we're not finding the magnitude too much today. All right, so obviously, you can see the direction pretty clearly on this picture, right? But if I have a vector that's the same length and goes the opposite direction, they're different, even if they have the same length. Okay? So the only way for something to be the same is if it has the same direction and the same length. Kind of makes sense? Okay. All right, so the easiest way to think of vectors when you're graphing is to think of it as plotting a course. Okay? You guys all use Google Maps, right? Or some kind of map quest of some sort. Do they still have MapQuest? Something close to it. And you know how when you plot out a course, it shows you, your route and everything, right? And we know that the shortest distance from where you start and where you end is what? You guys ever heard that? The shortest distance is in a straight line, yes? So the vectors are basically going to be that shortest distance, the resulting vector, the answer vector, okay? It's going to be that shortest distance from where you started and where you ended. Your work is going to be you showing me how you got there. Does that make sense? Okay, so that was a big question I always had of how do I show my work on this? All right, so let's show you guys how to do this. So when we do vectors, we use this notation. So you guys remember with a coordinate pair, you guys used parentheses, yes? If it was a solution set, you guys use these, right? Remember those squigglies? Okay? But with vectors, we use the little arrow ones, okay? The pointy parentheses. However you want to refer to it so that you remember. Okay? Now we also use another notation. If you're writing it, let me call this vector B. If we're writing it, we could put an arrow above it, which notates a vector. If you're looking in a textbook, it might be bolded. Okay? So it really depends. But most of you, since you're writing your homework down, you're probably going to be writing with the arrow on top. Okay? But you'll see on your homework assignment, I've bolded some of them. Because I'm using a computer, so I can bold it. Any questions about notation here? All right, so when you guys were plotting a point, x comma y, what did the x represent? The x-axis, the horizontal. Okay, so if it was a positive 2, what would you do? Okay, you would go to the right 2, yes? Okay, well, the value here does the same thing. You would still go to the right 2. But what about the b, which is the same as like y? Up and down. So that concept hasn't changed. The only difference is that you guys don't have an x and y plane. Sometimes we do put it in an x and y plane. But you don't need one. Okay? So let me show you an example. All right, so we're going to graph 5, 3, this vector, okay? And I'm going to call this vector, let's call it vector C. Okay. All right, well, this is telling us that we have a vector where we have to go right 5 and up 3. Yes?
Yeah.
Okay. Question?
You was referring
of like vectors in physics.
Mm-hmm.
In physics, like before every number or after every number, it's always direction behind it. So
Yes.
we do that in here.
When we get into direction, we will talk about that, but not so much. In physics, you guys are focused a lot on the direction because you guys are working with multiple factors, right? So there's multiple things happening to that vector to force it into a certain direction. Here in precalculus, I just touch on the basic operations. Do you know how to add, subtract, multiply, do dot products, all that stuff. So I focus more on the abstract, when physics focuses on the application. But we will get to the direction part in a couple of days. Good question. All right, so you can start anywhere you want. I'm just going to start randomly here. Okay? That's where I'm starting. Okay? And from that starting point, I have to go right 5. So I'm going to see 1, 2, 3, 4, 5. And I said up 3, yes? 1, 2, 3. So my vector would start where I started and end right there. That was a really sloppy one without a ruler. It's a whole lot easier with rulers. Yes?
Does it matter where you put it on the graph?
Oh, that's a good question. Does it matter where you put it?
Yes.
Yes.
Okay, well, let's test that theory.
No. It's the direction.
Well, let's test that theory because it's a good question. All right, so let me start somewhere else. I'll put it in green. I'm going to start here. All right, so 1, 2, 3, 4, 5. 1, 2, 3. So a good question that comes up and later on will be, are these two vectors equal? And the answer is yes. Because they have the same length, they both went right 5 and up 3, yes? And they're the same direction. So what's nice about this form is that they give you that direction and that length already. It's kind of built in, which is why we don't need the direction as much in this form. Okay? So these two vectors are exactly the same. If your friend turned in the green one, they would still be correct as yours if you turned in the dark blue one or the black one, whichever color it is to you. Okay? Now, I had another question that comes up. Well, what if I put it on a coordinate plane? Okay. So if you put it on a coordinate plane, then you would still go 1, 2, 3, 4, 5, 1, 2, 3. Wow. I really need a ruler with this app. Adding a coordinate plane to it, did it change anything?
No.
Nope. Does it change anything? I just pull away from that coordinate plane because I don't want you guys to get stuck on that it has to be at the origin. Okay? What do you think about plotting these? Kind of reminds you of slope, doesn't it? Rise over run, except for in this case, I guess we would run first instead of rising. So I have a lot of students start to think about as the coordinate pair as a slope. It's up to you, however you want to do it. All right, for those of you who can't see, this A is 1, 2, 3, 4 long. In case you were trying to count, because I know it's hard to see, but it's 4 long. And I drew the C by going right 2, up 3. So A, I went right 4. And then for C, I went right 2, up 3. Because I know that it's hard to see the lines up here on the screen. Okay? All right, so now we've done an operation. I have A plus C. Okay? What does it mean if you're adding something together? Does it get larger, smaller? Larger. And basically, we're calculating the distance of these two vectors, yes? So you got to think of this as Google Maps. Which was our first vector that they gave us? It was A. Okay, so I'm going to draw A. Because that's where I started, and then Google Maps told me to go right 4 miles, yes? Okay. So in Google Maps, when you make a turn, does it suddenly reroute you and put you back at where you started?
Yeah.
Or does your next direction come from the previous direction?
It's coming from the previous direction.
Comes from the previous direction. So, when I draw C, am I going to start here where A started? No, I got to start where I ended. That's the hardest part about this lesson. If you can remember that you need to plot your graphs, you always go from, we call it heads and tails, so you always go from tail to head, tail to head. Tail being, you guys have seen a bow and arrow, right? Tail is where the feathers go. Head is like the front part, the pointy part. So you hear me say tail to head sometimes. So here's tail to head. So I need to start with C where I left off. And we went right 2 and up 3, yes? So there's my Google Maps directions. Told me to go right 4 and then I had to go kind of right 2 more and up 3, yes? So that would be showing my work in the red and purple. That's what I'll be looking for. Do you have work on there? What's the answer? Well, the answer would be where we started and where we ended. So that would be your answer. This is A plus C. See how that works out?
Right, 2.
She was looking at the C one. So could I figure out what the coordinates, I'll call it coordinates, what the coordinates are of my vector A plus C? How would I figure that out? What if I wanted you to write it in this form for me, for A plus C? How would you figure that out? Yeah, you start where you started and you count, yes? Did we go right just 4? We went 6 because we went right 4 and then right 2 more. That's 6, yes? And then I went up 3. What do we think? All right, let me do a subtraction one, and then and then I'll do a scalar one, and we'll see how it goes from there. Anybody else still need this? Nope. All right, so same lengths. A is still going right 4. C is still going right 2 and up 3. Okay. Now we have 2 things going on in this example. I decided that I can combine it into one because you guys seem to be getting this. We have 2 times vector A minus vector C. What do you think that 2 is doing to vector A? Multiplying. It's doubling it, right? So I'm not going right 4. I'm going right 4 and then right 4 again. Yes?
Yeah.
Okay, so I can start off by doing that. That's not all that bad. So I would have vector A right 4. But I don't have one of them. I have 2 of them. So I just draw it twice. The hardest thing in the world, right? No, it's not. I promise. This is easy stuff. Especially my visual learners. They do really well on this part. All right, but the question comes in with how do we deal with a minus C? What is that minus doing? Opposite direction. Remember how I've told you guys that negative numbers is just a direction? The positive and negatives are a direction, right? We've talked about it in angles. I go, oh, the negative is just a direction. You go the opposite direction on the unit circle, yes? Okay, well, I'm prepping you for this. The negative C is a direction. So all that happens, and I'll draw what negative C looks like. Negative C looks like this. All I did is that wherever the head was, I put a tail. And where the tail was, I put a head. I just flipped it around. Am I still going the same length?
Yes.
Yeah, it's just a different direction. And in this case, I actually go left 2, down 3. Instead of right 2, up 3. Red fish, blue fish. Right. All right, so let me pick up where we left off because we did 2 A's. So this is where we're at. I said we need to go left 2, down 3. So my 2a minus c is here to here. That's what it is. Are we still subtracting 2? What do you mean by 2 of that?
Because you said we go right to.
Yeah, so remember on the purple one, we went right 2 and up 3, right? But minus c, in fact, let me label this, minus c, you go left 2 and down 3, because it changed the direction around. Okay? So in this case, you see how the green one right here, it went left 2 and down 3? So that's why this one is actually a little bit shorter than it could have been if I had added it instead of subtracting it. Okay?